students, let's see our paper CHO 4103, that is Basic Organic Chemistry. Friends, we are looking for the structural effects and their impact on acidity and basicity. So friends, we have studied these 6 structural effects in my previous lectures. First effect was inductive effect, second was resonance, third one was hyperconjugation, then steric effect, hydrogen bonding and tautomerism. So today we are going to start with a new topic, that is a basicity. So friends, as we know that 3 scientists work hard and explain us the concept of acids and bases. So these 3 scientists are Arrhenius, Bronsted-Lowry and Lewis. So in my previous lectures we discussed about the definitions of acids. So let's discuss about the definitions of bases in this lecture. So friends, according to Arrhenius, any substance which releases OH minus ions in water solution is called as Arrhenius theory. Okay, in Bronsted and Lowry theory, they explain that any substance which accepts a proton, that is H plus, is called as a base. And the third theory is Lewis theory. According to Lewis theory, any substance which can donate an electron pair is called as base. So friends, if we consider the organic bases, the last 2 theories we can apply to the organic bases, that is Bronsted and Lowry theory and Lewis theory. So in organic chemistry we will look for the compounds which accepts proton or H plus, and the protons which donates electron pair is called as base. So the simplest example is amines. So amines can donate the electron pair on the nitrogen. So I will say these are the bases. So let's see the stepwise how the bases and their strength is affected by structural effects. So friends, strength of organic bases, if we consider B and the lone pair on that B is a base, it will abstract the H plus and it will give the BH plus, that is conjugate acids. Okay, so friends, factor affecting strength of bases are as follows. There are 5 different factors that affects the strength of organic bases are availability of electron pair, second is stability of conjugate acid, third one is electronegativity of this B, and then fourth one is structural effect associated with this B, and lastly nature of the solvents. So friends, this type of factors affect the strength of bases. So let's see one by one with example. So the first effect or the first factor is availability of electron pair. As you know that bases are the compounds which donates electron pair. So availability of electron pair for the donation or for accepting the H plus is very important. So more the availability, more basic will be the compound. So let's see one by one. So I have the first example that is of methenamine and trifluoromethenamine. So friends, among these two, which one will be the more basic? So it will be only depend on the availability of lone pair on the nitrogen. So if we consider the substituent attached to the methenamine, this is a carbon, and to this carbon we have 3 hydrogens, whereas in trifluoromethenamine we have 3 fluorines. As you know that fluorines are more electronegative than the hydrogens. So if we consider trifluoromethenamine and methenamine, these fluorines have the minus I effect and they will attract the lone pair on the nitrogen towards themselves, and the lone pair on the nitrogen will be least available for donation. Hence it will decrease the basicity of trifluoromethenamine. Therefore in this example we have methenamine and trifluoromethenamine. Trifluoromethenamine will be the weakest base than the methenamine because of the minus I effect of the fluorine. Okay, this is how we are going to consider the other examples. Now in the second example, can you tell me among aniline and cyclohexylamine which one will be the stronger base? Okay, if we go for the examination, The question might be asked like that: aniline is weak base than cyclohexylamine. Explain. So if we consider the lone pair on the nitrogen of aniline and lone pair on the nitrogen of the cyclohexylamine, we can see that the nitrogen lone pair of this benzene ring or phenyl ring have minus I and minus R effect. So this lone pair will be delocalized in the benzene ring, and hence there is a less chance for the availability of lone pair for the donation. Whereas in case of nitrogen of cyclohexylamine, it is attached to the sp3 carbon having plus I effect, which increase the availability of lone pair for the donation. Hence cyclohexylamine will be the stronger base than aniline. If we consider the conjugate acids of aniline and the cyclohexylamine, the conjugate acid of aniline cannot be resonance stabilized, whereas conjugate acid of cyclohexylamine is stabilized by plus I effect of these two sp3 carbons. So if we consider aniline and cyclohexylamine will be the strongest base because of the higher probability or higher availability of the lone pair on the nitrogen. This is how the availability of lone pair is affecting the basicity of the bases. Now let's consider the next example. This following example, its name is hexafluoro 2-trifluoromethyl propane 2 amine. This following example is virtually neutral even though it have the NH2 group, because friends, the powerful minus I effect of 3 CF3 groups which are attached to the carbon which is attached to NH2. This powerful minus I effect of 3 CF3 groups decreases the basicity at such an extent that this molecule behaves like neutral compound because of the least availability of the lone pair on the nitrogen. So friends, this is how the availability of lone pair affecting the strength of bases. In the next example, we are considering the electron withdrawing groups which are attached nearby to the NH2 group. So in first example, we are considering morpholine and piperidine. So friends, morpholine is nothing but we have one more oxygen than the piperidine. So this oxygen at 4 position will withdraw the electron density towards himself, and the availability of the lone pair on the nitrogen is least available for donation. So if we consider morpholine and piperidine, in piperidine we don't have such kind of electron withdrawing group. So in this case the morpholine is a weak base than the piperidine. I will say the piperidine is stronger base than morpholine. If we consider the 2-chloropyridine and the pyridine, then friends, you know that the lone pair on the nitrogen of pyridine is available for donation because it is not taking part in the aromatization. Okay, it is not taking part in the aromatization. But if we consider these two example of 2-chloropyridine and pyridine, then this Cl group, which is electron withdrawing group and having minus I effect, this decreases the availability of lone pair on the nitrogen, and hence 2-chloropyridine is less basic than pyridine. So friends, this is how the availability of the lone pair is affecting the strength. Now as you know that amides are neutral compounds because the lone pair on the nitrogen is delocalized in the carbonyl group. So even though we have amide, can you explain me which one of the following compound is more basic? This one is amide and this is a cyclic amide. So this is a simple amide and this is a bridgehead amide. So among these, which one will be the more basic? So if we consider the bridged amides, this bridge position is not planar and hence delocalization of lone pair is not smooth in this case. Okay, so as delocalization is hampered by the bridgehead situation, then this lone pair on the amide of bridged amide is easily available for donation than the regular amides. So bridged amides are always more basic than the normal amides. Okay, so this is how the availability of the lone pair is important factor for the basicity. So friends, in next lecture we will consider the stability of conjugate base and strength of bases. So in the next lecture we are going to cover this topic. For today we will stop here. Thank you very much.